This is a video from section 6.4, and we're going to take a look at 17. A 10-foot chain weighs 25 pounds and hangs from a ceiling. Find the work done lifting the lower end of the chain to the ceiling so that it is level with the upper end. Now, I have a picture of a chain where at the top, we're going to call that 0 feet. In the middle of the chain, I'm going to call that 5 feet, and at the bottom of the chain is 10 feet. And so I'm placing the 0 at the ceiling with the positive direction going down. Now, the weight density, that's going to be 25 pounds, that's the weight of the chain, divided by how long the chain is, which is 10 feet. And so when I take 25 divided by 10, I get 2.5. And so that's 2.5 pounds per foot. Now, the part of the chain, X feet below the ceiling, where X is greater than or equal to 5 and less than or equal to 10, has to be lifted a distance of 2 times X minus 5 feet. Now, let's see if we can talk about that. And so I'm going to pick X right here. Now, that X has to be lifted from here up to here because it has to be level with the upper end, right? Now, the distance between X and 5 is X minus 5. And so are we in agreement that the distance between that point and 5 is also X minus 5? And so the total distance that that point traveled happens to be 2 times X minus 5. And so, again, the part of the chain X feet below the ceiling where X is between 5 and 10 has to be lifted a total of 2 times X minus 5 feet. And so remember, when we go back, we're finding the work required to lift the lower end of the chain. And so the total work is going to be the integral, right, from 5 to 10. Now, again, the distance is 2 times X minus 5. The force is going to be 2.5 pounds per foot, and then dx is represented by feet. So we're taking 2.5 pounds per foot times the number of feet. And that's how we set up our integral. We go over here. This is the integral from 5 to 10 of 5 times x minus 5 dx, which is 5 times 1/2 x squared minus 5x, evaluated from 5 to 10. And so when we make our calculation, we should come up with 62.5 foot-pounds. And that'll do it for this video for section 6.4, and we took a look at problem number 17. Okay, thank you.